Welcome back from the ad break, and let's continue with our lesson. Now we were busy with calculating the gradient. So let's look at a few points that we can, a few lines, where we can calculate that gradient. So we have been given a line here with points A and B. As we can see, A is 0 and 3, B is a -4 and a -5. Now remember, gradient is the vertical change divided by the horizontal change. So let's write down. Remember, we are using M to represent gradient, just like in that standard form, y is equals to mx plus c. So we are going to be looking at first the vertical change. So the vertical change, that is the 3 and the -5. So we can start off by saying that's 3 minus a -5. And we are going to divide this by the horizontal change, that is the 0. Remember, because with the vertical change, I started with point A. With the horizontal change, I need to start with point A again. It's very important. So that is going to be a 0 minus a -4. And that is the horizontal change. Now, what is 3 minus a -5? That is going to give us a +8. And what is 0 minus a -4? That is going to give us a +4. Now, what is 8 divided by 4, or what is 8/4? That is simply a 2. So it means that our gradient here is a 2. Let's move on to the next line here. And what I want you to notice with this next line, when we are comparing it with the previous line, this previous line was an increasing graph. And that's why our gradient was a positive gradient. So let's see what happens when it is a decreasing line. Now we are going to calculate the gradient over here as well. Remember, it is the vertical change divided by the horizontal change. So let's start with point B this time. But if I start with point B with the vertical change, I need to start with point B with the horizontal change as well. So the vertical change will be that 2 minus that -2. And we are going to divide this by the -3 minus that 5. Now this is going to be for the numerator 2 minus a -2, that is a +4. And then what is a -3 minus a 5, that is a -8. And our answer here is going to be A. So what is 4/8? That is going to be a -1/2. And as we can see, our gradient is negative. But why is it negative? Because our line is a decreasing line. And that's why our gradient is negative. Let's look at the next question, where we have more than 2 points on a line. We have there point P, point Q, and point S. But as it is noted there in our note, it says there, when points are collinear, they produce the same gradient. So we are going to see how true that is. Let's start with the gradient between P and Q. So remember, the gradient is the vertical change divided by the horizontal change. So I'm going to start with point Q, where I'm going to take the 2, and we are going to minus that -2. So that is the vertical change there. And then when we're looking at the horizontal change, we can say there's 0 minus our -5. So 2 minus -2, that is a +4. And we are going to divide this by 0 minus a -5. That leaves us with a +5. So our gradient here is 4/5. But let's see if we will find the same gradient if we use 2 other points. So we can use the same P, but this time let's use point S. So the gradient is the vertical change divided by the horizontal change. So this time let's start with point P. We have there a -2, and we are going to subtract a 6. And that is for the vertical change. And for the horizontal change, because I started with point P, I need to start with the -5. and we are going to subtract that positive 5. So negative 2 minus 6 is a negative 8, and a negative 5 minus 5 gives us a negative 10. Now, if we simplify a negative 8 divided by a negative 10, that will give us 4/5, and that would be the gradient again from points P and S. And the same would be if you were to calculate the gradient for point Q and S. Let's move on to the last concept on our concept map, and that is finding the equation of a linear graph. Now remember the standard equation. We have the output as our y, the gradient as our m, our x as the input, and we have the c as our y-intercept. Now how do we use the standard form to find the equation? So take note that to find the equation for a line, you need the gradient of a line and a point on that line. Now the point is to help us find the y-intercept. So you really just need the gradient and the y-intercept, because once you have the gradient and you have the y-intercept, then your formula or equation will be complete. So here's an example where we have a line that has a gradient of 3 and a point 3 and 8. Find the equation of this linear graph. So we start off with our standard form, y is equals to mx plus c. Then we need to substitute that gradient and that c. But because we were not given the y-intercept, it means we will use our point. Remember, our point is an x value and a y value. So we will use our point to substitute the x value there and to substitute the y value there so that we can find our y-intercept, which is the c. So what are we going to substitute in the value of y? The 8 that comes from our coordinate. Then what are we going to substitute for the gradient? We have been given, we are told that the gradient is 3. And what are we going to substitute for our x value? Remember, the x value comes from the coordinate that was given, or the point that was given, and that is also the 3. So when we look at that, 3 multiplied by 3 is 9, and we have c there. Then we use the additive inverse of a positive 9 to get the value of c. So that is 8 minus 9, and we can see there that c is a negative 1. Now once we have our y-intercept, we can complete our equation and say that our equation is y is equals to 3x minus 1. The 3 being our gradient and the minus 1 being our y-intercept. Let's look at this following statement. A line has a gradient of negative 2, that means m is equals to negative 2, and a point 0, 0. Now find the equation for that line. So this means that this line is passing through the origin, which is the point 0, 0. Let's find this equation. So we know that we start off with the standard form, which is y is equals to mx plus c. And this is because we already have the gradient there. So we are told that the gradient is a negative 2. Now we don't have the y-intercept, but we can find it using the point that we've been given. Remember, a point represents x and y. It is an ordered pair. So I'm going to substitute x with 0 as shown in the pair, and y with 0 as shown in the pair as well. And that is going to say now negative 2 multiplied by 0, that is 0. We are only left with c on this side and 0 on the other side. So the y-intercept here is 0. But what is the equation of this line? Now we know that the gradient is a negative 2. We have our x there and our y-intercept is 0. But if you think about it, because the point is passing through point 0 and 0, that means that it is passing both the x-intercept and the y-intercept at 0, which makes sense why the y-intercept is a 0. Let's look at the next question. A line passes through points A, 3 and 10, and B, 2 and 5. Find the equation of this line. Now for us to find an equation, remember we need the gradient and the y-intercept. So let's calculate the gradient for this line quickly. Now the gradient is the vertical change divided by the horizontal change. So let's take our 10 minus our 5, because our vertical change are those y values. Then, because we started with a for the first one, for the vertical change, we need to start with a again. So we are going to say 3 minus a 2. So that makes our gradient, what is 10 minus 5? That is going to give us 5. What is 3 minus 2? That is going to give us 1. So our gradient is a 5. Now that we have the gradient, we can use our standard form to calculate the y-intercept. Now what's interesting about calculating here, remember, for the gradient we are just going to substitute what the gradient is. But for the x and the y value, you can choose whether you use point A or point B. Any point on that particular line will work in finding the gradient. Let's take point B. So we are going to now say the x value for point B is 2 and the y value for point B is 5. And we are going to calculate based on that. 5 multiplied by 2 is a 10 plus c. We are going to use the additive inverse for a positive 10 to find that value there. So 5 minus 10 is a negative 5. We have our gradient is 5. And we have our y-intercept is a negative 5. And that is our equation for this line. Let's look at the last question there. And now we have been given a horizontal line. Now what is important to note about a horizontal line is that a line with no slope is a horizontal line. Remember, gradient means slope. So if a line has no slope, it means that the gradient is 0. So what does this mean for us finding this equation? Do we need to calculate the gradient here? We already know that there is no slope, meaning the gradient is 0. So what will the equation look like? So y is equals to mx plus c. We already know that the gradient is 0. We need to substitute a value for x and y. Now we can take either point P or point Q. Let's take point P. So that is x and that is y. So for point P, for the y value, it is 5. For the x value, it's negative 4. Now 0 multiplied by negative 4 is 0. That leaves us with c and 5. So what is the equation of this line? Y is equals to 5. And if you look at the line, it is passing where y is equals to 5. So that will be the equation for that line. This was a wonderful lesson. I really hope you enjoyed it just as much as I did. Thank you for joining in, and we hope to see you next time. Goodbye.